Hello. So today we're going to look at angles of elevation and depression. Okay. Now let's get to understand. So the angle that we have here is the angle of depression. Then the angle that we have here is an angle of what we call elevation. So here we are saying these two angles, if you to check, these two sides here are parallel and we call this alternate angles. So we are saying the two angles, if we are to call this A and if we are to call this B, we are saying A is equals to B, Y alternate angles are equal. So here we are saying alternate angles are equal. Okay. Equal. So alternate angles are equal. So you must know always that your angle of elevation is equal to angle of depression. But now, what are we going to be applying when you're on this type of what you call section here? We need to use Pythagoras theorem. Pythagoras theorem. Now, Pythagoras theorem, if we have got our hypotenuse there, if we have got our, let's say our opposite there, if we have adjacent, we say hypotenuse is equals to opposite squared plus adjacent squared, and our hypotenuse is going to be equals to root of opposite squared plus adjacent squared. But if you're looking for a smaller side, this one is our hypotenuse, the big longest side. So if you're looking for the smaller end of the smaller side, you have to subtract the other one. So here you will have to say hypotenuse minus adjacent squared, and this is going to be equals to, or is going to be equals to root of what we call hypotenuse squared minus adjacent squared. If you're looking for A squared, we're going to say adjacent squared is going to be equals to hypotenuse squared minus opposite squared, which is going to be equals to root of hypotenuse squared minus opposite squared. So I think now we can understand what we call these these formulas and not forget them. Okay. Then now, what else are we going to be using on this exercise? We'll be using the trig ratios. Trig ratios. So your trig ratios here, you've got tan, which is equals to tan theta, which is equals to opposite over adjacent. You've got cos theta, which we find by saying adjacent over hypotenuse. Then you've got the sine theta, which is going to be equals to opposite over hypotenuse. So what I encourage you to do is that always mark what is given to you, and mark what is also being asked of you. Now let's go to the next question here. Let's go to the next question here. The Cape Town cable the cable car takes tourists to the top of the Table Mountain. The cable is 1,2 kilometers in length and makes an angle of 40 degrees with the ground. Calculate the height of the Table Mountain. So here, what we are given here, we can look at what is given to us. Our hypotenuse is given to us. So hypotenuse is given to us. The angle also is given to us. So angle is given to us. And what is being asked here is the opposite side to the angle. So opposite side is opposite side is being asked of. So now we have to check now to say what is it that we need to use on the trig ratios here if we have got hypotenuse and opposite. So we have to think of sine. So sine theta uses opposite over hypotenuse. Okay, so here we have got sine 40, which is equals to our opposite is our h, which we are looking for. Then our hypotenuse is 1,2. So here our h is going to be equals to 1,2 times sine 40. Okay. Now, when you've got 1,2 times sine 40, we can try to punch here. Try to punch 1,2 sine 40, we get 0,77. So it's going to be 0,77. That's what we have there, 0,77 kilometers. So it's always what we call wise to check what is given to you, write down what is given to you. I am given angle, I am given hypotenuse, I am given opposite. So which now uses opposite and hypotenuse on your trig ratios. Okay, that's what you need to do. So let's move on to the next question here. An architectural design of the front of a house is given below. The length of the house is to be 10 meters. An exterior stairway leading to the roof is to form an angle of elevation of 30 with the ground level. The slanted part of the roof must be 7 meters in length. So if it means here, if we had to put it down here, it also means that it's 7 meters because this shows that these two are equal. Now, and if we are also to check here on the roof here, it means that BC and CD there, they are also what? They are also equal. So if I'm to check here, my length here down here is what is it? Front view, it's 10 meters, and it should be equal also to be equal to BD. And if you have to divide your your 10 meters, going to be 5 meters here. This one is going to be 5 meters. So it's always good to look on your diagram and try to find out what can you just what called deduce from your diagram before you actually attempt questions. Because once you attempt questions, for you to figure out some of the things to say, okay, this one length here is like this, is 10 meters as well. Sometimes it might be difficult, okay, because you attempted question. So calculate the height of the vertical wall. So we are looking for DE. Now, when you're looking for DE, let's deal with the triangle. Let's deal with the triangle FDE. So let's deal with the triangle FDE. Now, on triangle FDE, what is given to us? Angle is given to us. What else is given to us? Adjacent side is given to us. What else is being asked there? It's opposite side. So opposite side is being asked. So what can we use that uses what we call adjacent and opposite? That will be tan. So here we have our tan there. So we'll say tan theta is equals to opposite over adjacent. Okay. Now we have got the theta, so it's tan 30 is equals to our opposite over adjacent, which is equals to 10. So it means the opposite side there, which is DE. Let's put it as DE. We're just going to put DE there. DE is going to be equals to 10 tan 30. Okay. Then we come to our calculator here and punch 10 tan 30. We will find 10 root 3 over 3. So it's 10 root 3 over 3. That is going to be our final answer there. Now, the next question here is saying calculate the size of theta. So we are now looking for this theta here, the angle of elevation of the top of the roof A from the ceiling BCD. Now, when you look at this triangle here of ABC, so we're going to look at triangle ABC. We focus on that one. We are looking for theta is being asked, but what is given to us here is hypotenuse, which is equals to 7, and what else is given to us here is what is it? Our adjacent, which is equals to 5. Okay, so adjacent is equals to 5. Our hypotenuse is equals to 7. So what uses adjacent and hypotenuse is cos. So here, what are we going to do? We're going to say, okay, how do we get the theta? Cos theta is equals to adjacent over hypotenuse, which is equals to 5 over 7. And in this case, theta is going to be equals to arc cos of what called 5 over 7. So let's calculate here. Arc cos, shift cos 5 over 7. What do we get? We get 44,42. So the answer there is going to be 44,42 degrees. That's going to be our theta there. Okay. Now, let's look at the last part of the question. Calculate the length of AC. AC, what is it? AC, we can see AC is one of the smallest side. So what must we do there? We must not what called struggle to get that. We know that we are going to use Pyth now. We are using Pythagoras. How are we going to use Pythagoras? We are looking for the opposite side. So opposite side, opposite squared is equals to hypotenuse squared minus adjacent squared, which is equals to what is it? 7 squared minus 5 squared. So we know that our O is going to be equals to root of that 7 squared minus 5 squared, which we will get as, let's see here, root of 7 squared minus 5 squared, we get 2 root 6. So the answer there is going to be 2 root 6. That's our final answer there. So I think you guys, you understand now what you need what called to do when you are attempting these kind of questions. You need to apply what called the Pythagoras theorem. You also need to remember your trig ratios. Okay, so now on this next slide, we have got practice work for you guys. You need to practice. If you get the answers, you can WhatsApp them what called to me to check what called on the number on the first slide. Thank you so much. Until next time. Bye-bye.